This conference will now be recorded.
Thanks, Rochelle. So welcome everyone. I'm going to just take you through a few slides introducing NICOLA before I hand over to Steve McEwen, who will be doing the webinar today. Just before we start, another reminder, please put your microphones on mute and your videos off. And then just remember at the end of the session, we will flash up a little password to get your CPD points. So please hang around till the end of the session when we flash up that password. So getting going on NICOLA. Firstly, just before we start introducing NICOLA, I thought it would be good to have a health and safety moment. So my health and safety moment today is just looking at mental health and sleep hygiene, because to be honest, sleep is something I struggle with personally, so I thought it'd be quite useful to share some of these tips. So with the COVID pandemic at the moment, it's been very disruptive, and there's a lot of extra stress, a lot of pressure on mental health, and getting the right sleep is very important to mental health. So I've just got up on the screen a couple of extra tips to help with getting more sleep or getting better sleep. So these include things like avoiding stimulants just before bed, getting exercise, avoiding heavy or fatty foods, getting enough natural light, which is easier in some places than others, I suppose, at least we're not in the UK. Just getting a regular nighttime regime or pattern in terms of when you go to sleep and when you wake up. And if you are struggling to sleep at the time, just trying to use breathing exercises to relax and slow your heart rate, and avoiding your phone, reducing blue light before you go to bed. So that's just my little health and safety share for today. For those who are not members of NICOLA, I do just want to introduce a little bit about what we are. NICOLA stands for the Network for Industrially Contaminated Land in Africa. So this is a member organization, which is a non-profit organization, which aims to provide a forum for exchanging information on good practice, practical scientific knowledge, exchanging ideas to manage contaminated land more sustainably. And we do this through a number of mechanisms. We have several working groups on relevant topics. And Steve McEwen, who's presenting today, is actually presenting on one of our topics. He's the lead on that working group. We do have contaminated land training, and we also have our annual conference. Pre-COVID and hopefully post-COVID again, we would do some networking events, which includes some evening events, some seminars, webinars, such as this one, and industry forum events. So we look at coordinating and stimulating communication between various different parties, including industry, mining, academia, regulators, service providers around the fields of hydrogeology, geochemistry, and waste management. A feather in our cap last year was an award which we got at the Coro for contribution to land remediation in South Africa, and that was given to us by the Department of Environment, Forestry and Fisheries. So we normally have an annual conference. This year was going to be something a bit special. We were going to have an internationally recognized SUSTREM conference. Unfortunately, with the COVID outbreak, that we've been forced to push that out till next year. So we are still very excited about this conference, the SUSTREM 2021. It's, as I said, it's an international conference that's been hosted at various locations around the globe. And it will be hosted next year in Cape Town at the Spear Wine Farm in October. We have quite a lot of information about the conference up on our website already. So please do have a look. If you're interested in getting involved or being a sponsor, please do reach out to us as well. We will hopefully be putting tickets on sale towards the end of the year. So this is obviously one webinar in a series of webinars. The next webinar is going to be on the potential of bioremediation principles and case studies given by the Green Soil Group on the 9th of September. So please put that in your diary if it's something you'll be interested in. As mentioned before, these webinars are CPD accredited. If you are a NICOLA member, we'll get that CPT accreditation for free. If you are not a member, but you would still like the CPD certificate, you'll just need to reach out to our admin email and contribute towards getting that done. So I'm now going to hand over to Steve McEwen. Steve is a partner in ERM, which is where I work as well, and he is leading the VI, Vapor Intrusion Working Group within NICOLA, and he's going to be presenting on some of the findings and the information that they've put together. So thanks very much, Steve. I'll hand over to you.
Thank you, Margaret, and welcome everybody. I hope everybody can hear me. Maybe if Margaret, if you want to confirm that you can hear me, then hopefully everyone else can too.
Yep, I can hear you and see you, so thank you.
Okay, great. I'll try not to scratch my face. This is a first for me doing it virtually. So thanks. Yes, my name is Stephen McEwen and I'm a partner at ERM. I work with Margaret. I've got about just a bit more than 20 years of experience in environmental consulting. A lot of that time I have been involved in vapor intrusion assessments in one way or another, and I'll be presenting on that today. So I am currently, as Margaret said, the champion of the Vapor Intrusion Working Group within NICOLA. So this is something that we hope to develop guidance around, and I will present some of that information in this presentation. So with that, I'll get going. So in terms of what we're going to cover today, I'm going to give you some background on vapor intrusion. We're going to look at a little bit of what local legislation is available and some of the challenges that we have here. We'll go into some of the available sampling methods. We'll look at vapor migration and the attenuation of vapors within the subsurface and also within buildings. Then we'll look at methods, briefly look at some methods for mitigating against VI. And then finally, I'll touch on what we are doing in terms of vapor intrusion at NICOLA in terms of our position paper and the guidance document that is under development. So firstly, what is vapor intrusion? I'm sure this won't be new to some of you. I'm sure many of you are involved in these sorts of assessments already, but it's basically the process by which volatile vapors will partition from a contaminant source, which would either be a soil or a groundwater source of contamination from a petroleum tank or from a solvent release into the ground, as you can see in these images, and then that would allow volatile vapors to partition through the subsurface environment and potentially affect occupied buildings above that, as you can see in those images. And broadly speaking, vapor intrusion is subdivided into what we call petroleum vapor intrusion, or PVI, and chlorinated vapor intrusion. And the reason for that is that the attenuation of vapors in the presence of oxygen is a key process in terms of petroleum compounds, and it's not a process that is typically seen with chlorinated solvent compounds, which biodegrade anaerobically. So there's a distinction between some of the processes that happen in petroleum VI and some of the processes that happen in chlorinated VI, or CVI. So in terms of guidance that is available internationally, there are some key documents which I've put up on this screen. Mostly it's the understanding of VI is led by the Interstate Technology and Regulatory Council, or the ITRC, in America, and also the US EPA. So they've produced guidance documents in the early sort of 2010s, so 2014 and 2015, and that is essentially the best practice understanding of VI is captured in those documents. Also, CRC Care, which is an Australian organization, has published a document, their guidance document on VI in 2013. So in fact, in the early 2010s, when this was quite a hot topic, there was a little bit of a power play, I guess, between these organizations to try and see who could get out their document, their guidance documentation first, and the Australians actually ended up getting theirs out in 2013. But they're all essentially cover similar things, the methodology and the approach to VI is not very different between these documents and between these organizations. And in fact, many of the people that have worked on these various things, whether they're in EPA or ITRC or CRC Care, have consulted with one another, and they work quite closely together anyway. So it is consistent. It's not as though you would open one of these guidance documents and see something that is very different to one of the others. So that's the key guidance that we also utilize here. So just in terms of local contaminated land legislation, and I'm sure this will not be new to you in the work that you do. I'm sure that you've come across this and you follow these principles. So, but just to give you some background, or to outline what we have in South Africa, there's obviously NEMA, the National Environmental Management Act, and the National Water Act, promulgated in the 90s, and they provide provisions for the prevention of pollution and remediating the effects of pollution. They're general duty of care principles, but there's no specific methodology of how you should go about remediating pollution. And therefore, later on in 2008, the National Environmental Management Waste Act was promulgated. And as part of that, Part 8 of that Act provides a provision for which specifically deals with contaminated land. And then later on, in 2014, they published norms and standards, which included soil screening values for a range of contaminants that we might find in the environment, and how to screen against those in different land use scenarios, including industrial, residential, and so on. Another guidance document which is key to, in fact, the NEMWA and the norms and standards is the framework for the management of contaminated land. That guidance document was published in 2010 and promotes a general risk-based approach, which is what we would endorse in our environmental assessments. And it also provides soil screening values, which were in fact using the approach and adopted in the norms and standards that were published under NEMWA in 2014. So those essentially come from the methodology that was published in the framework document. In South Africa, there's also drinking water guidelines, which the SANS 241, which are essentially based on the WHO guidelines. And then also, which I haven't listed here, there are occupational health screening criteria for air contaminants, but those are not risk-based screening levels. They're more industrially based screening criteria, and so there's no actual vapor intrusion legislation or guidance in South Africa. So what we do need to do is follow the principles of using the risk-based approach, which has been put forward in the framework, and then also using the best practice guidance documents, which I've just shown you from ITRC and US EPA and so on. So some of the challenges we have in this country: vapor intrusion does remain largely unassessed because there's no legislative drivers for doing these investigations, and no currently available guidelines. VI does actually represent one of the most significant exposure risks to VOCs in the environment, because very often, especially at industrial sites, people don't typically drink the groundwater, and they're not necessarily in contact with the soil either. So what you're left with is the potential for a vapor intrusion risk to the buildings that you're in fact working in or occupying. So as I said, South Africa does have a risk-based framework, and that can be used as a basis for developing VI guidance. There's limited availability of sampling equipment for capturing vapor samples and also for analyzing them in South Africa. So there's limitations there. Often we have to, or mostly we have to submit our samples to international laboratories to get them analyzed. And then we use international guidance in terms of the methods of sampling and screening of risks. So what ultimately happens is that due to these logistics and foreign exchange considerations, the costs of these assessments does go up relative to the cost of, say, a simple soil or groundwater assessment, and for that reason, you know, it's more expensive to do this in South Africa, and that might be why there's less of these assessments. I have to say that it is increasing, and that a lot of consultancies and clients are understanding the risks of VI now and starting to do more of this. And I know that many of you on this call are probably also involved in VI assessments, and so it is becoming a more widely understood risk in South Africa and is being addressed more and more. So in terms of sampling methods, broadly speaking, vapor sampling can be classified into two categories, either active sampling or passive sampling. So active sampling refers to extracting a sample of vapor of a known volume, and that will give you a quantitative result of how much of a contaminant per meter cubed of air you would have within your building or in your outdoor environment, wherever you've taken your sample. So there's an image on the top right which shows you schematically how that setup would be. You'd have something like a Suma canister, which is a vacuum canister that you collect your sample in, and you'd have a sample train attached to a pin or a vapor well, which is going into the ground and collecting your sample from the subsurface. You can also obviously collect ambient air samples simply using the vacuum Suma canister in an indoor environment. Also shows you in that figure how helium is used in a shroud to determine potential leaks in your vapor sampling setup. Then in terms of passive sampling is essentially where you would leave a sampling device. It's normally an adsorbent sampler of some nature, which you put into the ground and you leave there for a period of time. It could be a week or 2 weeks. And you come back and retrieve that sampler and analyze that for your volatile contaminants of concern. And that would give you a qualitative idea of how much contaminant is there. It's not going to be mass per volume, but it is going to give you a broad understanding of where your hotspots are on your site or where your source areas are. And it is a cheaper method, and often what is used, the way passive sampling is used is on a grid basis where you know very little about your site or about your contaminants at your site. And if you're trying to understand where the source areas are, it's often useful to start with a passive sampling event and then move over to an active sampling. So these are just illustrations of what it would look like. On the left-hand side, we've got what we would call a vapor well, which is installed very similarly to a groundwater monitoring well. You'll have your probe with apertures in it to allow the vapor in, and that would be surrounded by a clean silica gravel pack, same as a groundwater monitoring well. That will be attached to a nylon tube or some sort of a tube where your sample can be collected to the surface, and you seal that with bentonite. The middle picture shows you a picture of a vapor pin, which you would install through a slab of a building or outside on a concrete slab just to the subsurface environment, and that allows you to collect a sub-slab sample from your beneath your floor slab. And then the picture on the bottom right is just a proprietary product called a Cox-Colvin vapor pin, and that's just very similar to the other vapor pin example, but it's where you wouldn't have to use grout to grout the pin in place. It would have some sort of a silicon seal, which allows you to seal it off from the subsurface. So those can also be used, and there are similar devices to that as well. So just some photos showing on the left-hand side a soil vapor well, and that's just the tube coming out of the well while it's under construction, and the sand that would have been used as the gravel pack. The middle image here shows an example of a shroud, and a shroud doesn't necessarily need to be a fancy proprietary device. A simple plastic box that more or less seals onto the ground is sufficient as a shroud, and this is filled with helium gas from a helium canister, and that allows you to check for leaks in your vapor pin installation. You fill the shroud with helium, and you have your sample set up and your sample train connected to your canisters. In this case, we've got a duplicate sample being undertaken here. We've got 2 Suma canisters connected to the vapor pin via a T device. And the idea is that you would not expect to get helium inside your canister, because that is the sample that you're collecting from the subsurface. You hope that the helium would only be present within the shroud. So if you do pick up helium within your sample canister, then that suggests that you have a leak in your vapor pin. So this is your helium detector, and you detect the concentration of helium within the shroud, and then at the lab, they will also analyze for helium within the canisters to see if you've had any leakage coming through. And then on the right-hand side, just showing you an example of a Suma canister for collecting a sample in an ambient scenario. This could either be outdoors or indoors. If it's indoors, it's normally put at a location which is around about the breathing height of a person in a building, and that sample may be collected over an 8-hour or a 24-hour period. So this is just an example of a site where we have done a passive soil gas survey. And what you can see on this slide is a comparison with that data, which is the color flood in the background, and groundwater data from the same site. So the passive soil gas survey would have been done on a grid basis. So you would put a grid of passive soil gas samples across that site. You would then get them analyzed. In this case, the contaminant was TCE, or trichloroethylene, at this particular site, and you can see the color flood shows you the areas where the higher concentrations of TCE are present in red, and the lower concentrations in green. And then overlaying onto that are the groundwater well positions at that site which were installed, and you can see that the higher concentrations of TCE in groundwater roughly correspond with the areas at the site where particular down here in the south where we picked up the high concentrations in the soil vapor. So it shows how you can identify particular source areas at your site by doing the passive soil gas survey. The next image is the same site, and it's the same color flood. The colors have changed here, but this is essentially the same passive soil gas data that I just showed you on the previous slide, and this is overlain with active soil gas sampling. So this is in buildings at the site where we've taken the IAs or indoor air samples and the SSs or subslab samples in various areas, and you can see that once again your hottest areas for TCE in your active sampling correspond quite closely to the areas in the passive soil gas survey where you also picked up the highest concentration. So it's just showing you how the data for passive versus active sampling does actually correspond quite nicely. So then, just in terms of the conceptual site model, this is a diagram that just broadly shows you some of the processes that are happening in terms of vapor intrusion. And like with any investigation, it's always useful to develop a conceptual site model of your site to understand what your risks are and what the issues could be. So here you can see that you have a petrol station, for example, with underground storage tanks which might have leaked, and the leakage would cause LNAPL, which then floats onto the groundwater table and creates some sort of a dissolved phase plume. And you will have volatilization of your VOCs either from the LNAPL itself or from the dissolved groundwater plume, and they'll migrate upwards via diffusion. And as you get closer to, let's say, an occupied building, you will have advection that takes place closer to the building slab, which will either prevent the vapors from going inside the building or allow them in, depending on the pressure gradient. And then other influences that might be at play, like outdoor airflow and so on. And it also shows you, you've got oxygen that diffuses from the surface into the subsurface, and that will also create a zone of biodegradation, which we'll touch on in a minute. So in terms of vapor migration, as I've said, you'll have from your contaminant source, which in this case is a dissolved groundwater plume, you'll have partitioning of your volatiles into the vapor phase and slow diffusion upwards towards your building. What's key to note, and you'll often see it in these diagrams, especially the diagrams that are in the American literature, is that there's often a basement area, which is shown on the diagrams, because buildings in the US are commonly have basements, whereas buildings in South Africa don't have basements. So the compliance point that you would choose, which would be the start of your potential vapor intrusion issue, would be the lowest slab of the building. So in this case, it would be the slab of the basement area and not the slab at the ground level. If you don't have a basement, then obviously it will be the slab at ground level. And that's where, if that's an occupied space, that's where vapor intrusion could occur. So diffusion is obviously a concentration-driven gradient process where it'll move from a high concentration to a low concentration. So if you've got your groundwater plume, the vapors will move upwards away from the high concentration of the groundwater. Whereas advection is a pressure-driven gradient. So either you will have a greater pressure outside the building, and that will discourage or cause vapors to move outwards and not into the building. Or if you have a negative, if you have a more negatively pressurized building on the inside, then that would encourage vapors inwards. So that we'll discuss in a minute as a way to mitigate against VI. So then just touching on the biodegradation or the bioattenuation. So this is a process that for petroleum vapor intrusion, the rate of degradation in the subsurface is far greater than the rate of diffusion of the contaminants coming through the profile. And that's a good thing, because what that means is that you get, in many cases, almost complete biodegradation of vapors as they migrate upwards from a groundwater or soil or LNAPL source towards a building. And so you can see here on the right-hand side, you've got a PVI example. So this square represents, the bottom of the square is the source in the groundwater, and the top of the square is the ground level itself. And what happens is, at the source area, you have very little oxygen. You have an anaerobic zone, and your petroleum hydrocarbons will migrate upwards at a great concentration. So this is just 0 to 1. So 1 being 100% of the petroleum hydrocarbon concentration. And as it moves upwards, as soon as it gets into contact with oxygen, there's a very narrow zone where all of the biodegradation will take place, and it will deplete your petroleum hydrocarbons as they get move upwards towards the building. And that basically creates a zone where you can have full attenuation and not need to be concerned about vapor intrusion. Alternatively, in terms of chlorinated VI, these compounds degrade under anaerobic conditions, and therefore if you have a presence of oxygen in your soil, there'll be very little degradation of these compounds, and they will migrate upwards and could present a VI risk. So there may be some decrease of your chlorinated hydrocarbons, but that's effectively just because of dilution or dispersion within the profile rather than biodegradation. So this is just another way of depicting that for petroleum VI. So you will have your source zone, which would be, in the case of LNAPL, the drawing on the left-hand side, the top of the smear zone, because you'd have a water table that potentially moves up and down seasonally. At the top of the smear zone, or the highest water table, would be the point that you would start to calculate the distance from your source to your receptor, which being the basement or the building slab of the building. So that would be the distance that you'd calculate. If you're looking at a dissolved phase plume, like the diagram on the right-hand side, it would be the position where you've got the highest water table to the building slab of the building. And as I said before, the presence of oxygen diffusing down into the soil is a key process, and there'll be a narrow reaction zone at some point where the petroleum compounds would degrade effectively before reaching the building. So this is just it just shows you some of the research that has been undertaken over time in terms of vapor intrusion. And you can see in the early days, the US EPA, when they were looking at vapor intrusion, they were promoting distances of 30 meters in depth for the hydrocarbons to be completely degraded or not to reach a building. And that was before they understood the role of oxygen in the subsurface. So the separation distances, if you like, were initially much larger before they understood that. And as that research progressed and the understanding of oxygen was better understood, you can see that what these various authors have proposed is much smaller separation distances, in some cases 0 for lower concentrations of contaminants, to what is broadly understood now in terms of the guidance. You know, these are the guidance documents that we're following at the moment, and they're proposing separation distances of between 2 and 5 meters, depending on whether you have dissolved phase or LNAPL. So this is some data that we have collected locally, and what we are seeing here is a plot of the vertical separation distance on the y-axis. So 0 being at ground level, and then these numbers increasing with depth. So it's kind of in the opposite direction that you'd expect. So it's surface to depth, and then on the x-axis we've plotted groundwater benzene concentration. So this is a plot of benzene data in particular, and we've plotted groundwater concentrations versus vertical separation, and then the colored blocks represent the corresponding subslab soil gas concentrations at those same locations. And what this means is that where we see the little blue diamonds, that indicates no risk. So in other words, these subslab concentrations are at a concentration which does not represent a risk to indoor air in terms of available screening guidance. And then all the other colored symbols, the yellow, red, and purple symbols, indicate where there could be a potential risk. I mean, once again, this does depend on the attenuation factor across the slab, which we will discuss shortly. But it does indicate, you know, that there may be a risk. So what this data shows us is that at a 4-meter vertical separation, there's no risk to indoor air at any of the sites where we gathered this data. and also at a concentration of less than 1,000 micrograms per liter of benzene in the groundwater, there's no risk to indoor air regardless of the separation distance. So, I mean, that's very useful that we were able to collect local data which actually corresponds very closely to what other authors and the EPA and the ITRC have seen, which goes to show that you know, the situation in South Africa is very similar to what others are finding elsewhere. So then, just touching on modeling, you can also model vapor intrusion. There are various models available, and some of these models have been available for a long time, like the Johnson-Ettinger model. That model does have limitations in terms of considering biodegradation of petroleum compounds. So it is a conservative model. If you're running a Johnson-Ettinger model, you must be aware that the concentrations that they may predict from a contaminant source, let's say groundwater to indoor air, would probably be higher than what they will be in reality. Other more recent models that are available are BioVapor, and PVI Screen is an even more recent model, which is a variant of BioVapor, and those models do take into account biodegradation, so they'll give you a slightly more accurate result. But what we typically say is that collection of site data would be preferred over modeling, as a minimum to try and collect sub-slab data, which would have less variation. It will have some seasonal variation, and you do need to collect multiple data points rather than just one, to try and see whether you in fact do have a risk or not. I think where models can be useful is where they predict no risk to indoor air, because the models are typically set up conservatively, and provided that you're using appropriate input data, if you're running a model and it predicts no risk, then the likelihood is that there won't be a risk, because, as I say, they typically use conservative inputs. And then you also need to consider the attenuation that will occur across a foundation slab, and whether or not these vapors can get across the slab or through the cracks or diffusing. Okay, so looking at attenuation factors across slabs, this is just some information that comes from the US, where they've done a lot of research on this. Various states in the US have proposed attenuation factors, so that's the concentration in the subslab versus what it would be in indoor air, and how much attenuation is likely to take place. And that varies from about 10 times attenuation to 1,000 times attenuation, depending on which state you're talking about. The US EPA has suggested an attenuation factor of 0.03, which is 30 times attenuation from subslab data to indoor air. And these attenuation factors have been derived using an extensive database of information, which I will also show you shortly. And typically the way it's done is to use paired indoor air data and subslab data from the same location, and then to compare those two. And the 95th percentile is used to derive the attenuation factor. So the attenuation factor, as I've just said, is the concentration of the indoor air divided by the concentration of the soil gas. And that would give you, for example, what we saw here, the 0.03, as being an acceptable, or as being the likely attenuation on average. So if you know what an allowable indoor air value is, or a screening value for what's allowable in breathing air, then you can estimate what the concentration of soil gas could be that would pose a risk. So your indoor air divided by your attenuation factor will give you the acceptable concentration of soil gas. And if you know the soil gas concentration, then you can obviously also change the equation around and work out what the indoor air concentration would be. So this is the US database that I've just spoken about. It's freely available on the internet. It's an Excel file, and these are the data points that they've got in their database. And this is indoor air concentrations on the y-axis versus sub-slab concentrations on the x-axis. The red line represents a 1-to-1 ratio, so that's where we're saying that the sub-slab concentration will be the same as the indoor air concentration. And where you would have that type of relationship would typically be where there's a breach in the floor slab, or in fact where there are indoor air sources themselves, which might create this scenario of where you have higher concentrations in indoor air than you do in the sub-slab. And the data here is showing you in light blue, it's where the indoor air values were less than the detection limit or the reporting limit, and the dark blue values are where the indoor air result is greater than the detection limit. So then what we've done is we've superimposed onto that same database some local data that was collected in South Africa. And what is very nice to see is that the data that we've collected here is very similar to what they found in the US. So the data points here, the light green and the dark green points are local data, which has been collected at various sites in South Africa, with the light green being where the indoor air value was below the detection limit, and the dark green spots being where it was greater than the detection limit. And what you can see from this data is that in fact, we only found 2 data points where the indoor air concentration was greater than the sub-slab concentration. And in both of those cases, it was in fact confirmed that there was an indoor air source. In the one case, it was benzene. There was benzene in indoor air. And in the other case, there was PCE in indoor air. So that's where the PCE concentration was greater than the sub-slab concentration. So just breaking up some of the local data that we had, this is workshop or industrial air environments in shop floors or in industrial areas, not office buildings. And here we can see the spread of data very similar to the previous diagram. And it's going from a 1-to-1 ratio to a 1 in 100,000 attenuation factor from sub-slab to indoor air. Then if we look at the data for office buildings, these are occupied office buildings where there's no sort of workshop or production activities going on. And you can see what you would expect is, firstly, the attenuation is a lot more. So in fact, it's from about 10 times attenuation to about 10,000 times attenuation from the sub-slab to the indoor air. And it's in areas where you wouldn't expect there to be an indoor air source, because it's in a general office building with no specific chemicals that are affecting the indoor airspace. And then just breaking
Steve,
that up further yes.
So, sorry to interrupt, just to give you a time check, we've got 15 minutes left and we will need to have some time for questions. So just to let you know.
Yes, I'll be wrapping up shortly. Thanks, Marge. Thank you. So just breaking this up into different office buildings, you can see that it becomes even narrower. And I think the important message here is that if you understand your building well, and if you have enough data points, you could actually develop an attenuation factor that was specific to your building. So here you can see that it's for this particular building, there's a very narrow range of data points, and you could probably safely calculate an attenuation factor for that particular building. And the same goes for this second building, where all of the data plots at more than 1,000 times attenuation from the slab to the indoor building. Then looking at briefly at vapor mitigation methods, there's various different ways that one can mitigate against VI. If there is VI coming into a building, there's vapor barriers, there's spray-on barriers, there's geomembrane barriers that can be applied to buildings generally when they are under construction. You can also look at changing the air conditioning systems or ventilation to a building to try and change where the vapors come in. And then another useful method is depressurization of the floor slabs, and we'll go into that in a little bit more detail on the next slide, to prevent vapors from coming into a building. So these are sub-slab depressurization is the system that we've applied to various buildings in this country very effectively. And it's a simple process of using an extractor fan. There's a picture of the extractor fan on the right, connected to a sump beneath the building, and you effectively create a vacuum in the sump, and basically you're negatively pressurizing the sub-slab environment or the outdoor environment relative to the indoor environment. So you're basically creating an advective flow away from the building rather than into the building. So it's a very simple method of, this is showing you the sump through the floor, of encouraging vapors to move away from the building and not to move into the building. And with this, we do what we call diagnostic testing. So while you're constructing these SSD systems, you can connect an industrial vacuum cleaner to your sump, and you can apply a vacuum to that and then take pressure readings at points set distance away, and you can work out what your radius of influence is before you in fact install the system. So you can understand how many sumps you might need in a building to make it effectively cover the whole building slab. And so this photo shows you exactly that. This is a building footprint where we installed 2 sumps, and using the diagnostic testing method and various points away from these, at various distances away from these sumps, we could work out that it was exerting an effective pressure which was sufficient. It needs to be at least 1 Pascal of pressure, and it was sufficient at all of these points to fully cover the footprint of the entire building using these 2 sumps and the extractor fans on the outside of the building. So then just moving on to our position paper, and I'm nearly done now. It focused on, the management of VI related issues, and drawing on the guidance from EPA and ITRC, provides a brief background, and it promotes a sustainable risk-based approach, which is in line with our legislation. And our position is effectively to develop your conceptual site model, evaluate your risks using the standard risk-based approach, and where unacceptable risks are identified, to develop an appropriate sustainable risk mitigation. And in the position paper, we've also included the important reference documents. Then looking at the technical guidance document, which is still under development, this is intended as a practical guide to the management of risks from VI, and it's being prepared in accordance with the international literature, which I've spoken to you about. The important aspect here is that it's not intended to introduce new scientific concepts. We aren't doing our own specific research apart from collecting data which corroborates the data that we are seeing from other areas. But it's using the guidance that's out there and putting it into a usable format, focusing on the issues that are specific to us in South Africa. So it's aimed at us environmental practitioners, owners of contaminated sites, and also regulators. So the structure of the document, the intended structure of the document is conceptual site model, looking at biodegradation within the VADA zone, briefly touching on some of the available models that are out there, not going into specific details of these, but just an understanding of what is available, and some fate and transport modeling considerations. We'll look at vapor control and mitigation, sampling methods, as I've mentioned in the presentation, and then also developing simple VI screening levels for indoor air using available algorithms or equations as put forward by the US EPA, and using risk levels which have been specified in the South African framework document, which is a hazard index of 1 in 100,000 carcinogenic risk. So with that, I will hand back to you, Margaret, and thank you very much, and happy to field any questions or take any comments.
Thanks very much, Steve. That's great. I got a quick question. The guidance document you're talking about, is it specifically PVI or is it VI in general, including both types?
We did think about that, and there was a school of thought that we should focus firstly on PVI and then get to the CVI. But the feeling was that, you know, if we end up producing a document on the one and not covering the other, we might never get to it. So I think the intention is that it will cover vapor intrusion as a whole, but obviously the aspects that are specifically related to PVI will be covered and will be addressed. So it's going to cover both. It's going to be VI as a whole.
Perfect. Thanks, Steve. Can everyone see my screen? It is the CPD password. Steve, can you see my screen?
Yes, I can see
Okay.
it. I'm sure everyone else can as well.
All right, so I've flashed it up. The password is yellow peaches. And then I'm going to stop sharing now so I could have a look and see if there are any questions. So Haley has asked in the chat box, can you comment on best practice for assessing VI, considering which sites sit directly on fractured bedrock? That's from Haley Thomas. Steve?
Oh, that's a good question and quite a complicated one. Thanks. We haven't specifically looked at fractured bedrock risks, but I would say that the assessment of, well, in terms of the sampling would be similar to other sites, but it is in fact something that I did discuss with Matt Davis when he was here, and as far as we know, there's no specific guidance on fractured bedrock, and it would be something that we would have to do specifically in South Africa. So I haven't considered that specifically, I have to say.
Okay, thanks, Steve. And then Brandon McGugan has asked, yes? Do you have a question? Hi, Tendo.
Yes, Margaret. I have a question for Steve. I just want to check with you if you have found out when you look at the soil type, if the soil type plays a significant role on the vapor intrusion. If that is the case, does the soil type taken into consideration in determining the emission factor?
Yeah, that's a very good question. Soil type is obviously relevant, but what we have found, and that research that I showed you for separation distances in particular is, and I should have mentioned that, is regardless of soil type. So we are seeing that relationship of separation distance and what's been calculated for separation distances is valid whether it's a clay soil or a sandy soil. So yes, of course, one does need to consider the soil, but the separation distance criteria are valid for both. And I see, Margaret, I can see Brandon's question. So let's, that is unfortunately $1 million question, Brandon. I'm working on it, and I was going to try and make sure it was done this year by the conference date. Now we're not having a conference, so I will still endeavor to get it done before the end of the year.
Yeah. Steve, can I clarify? I mean, you're talking about getting the guidance document complete, right? Because the actual initial position paper
is complete, but it but it has to be said that's really just a position. It's a one-page paper and it presents you with references and an approach, but it's not the guidance document. Yeah, that's right. Thanks, Margaret.
So, Steve, when Margaret or yourself started, you made mention that there is no regulatory framework in South Africa, which is true in as far as the vapor intrusion is concerned.
Yes.
In putting up this position paper, will it be something that perhaps can be presented and pitched to the regulator so that they do understand the impact and the risk associated to the vapor intrusion aspect in issuing the remediation order? Because I have seen a number of remediation orders just being issued for the sake of being issued without considering other risks associated to maybe perhaps the building structure closer to that area. Yeah, but you find that remediation order being issued, and they are forcing industries or consultant to go and implement something that does not address perhaps the problem on the ground.
Yeah. So look, firstly, what NICOLA does will not be legislation or regulation because it can't be. So we're not working for government. But having said that, we do know that in consultation with the DEA or the DFF, they are very comfortable with the work that NICOLA is doing, and they are looking to us to lead this area of contaminated land because they are conscious that they don't have budgets to promulgate lots of different regulations. So I think they are looking to us to provide best practice guidance, but it will just be that. But I think these are conversations that you need to take to the DEF, and we certainly have, and they are on board with the approaches that we promote and the position papers. But as I say, it's not regulation, but it is something that my understanding and hearing this firsthand from people within the DEF, they are looking to us to develop this kind of guidance that hopefully can be followed in the industry.
I can tell you the last document on the remediation in South Africa was ended with my time in the Department of Environmental Affairs, which was the norms and standard for regulation. I mean, the norms and standards of contaminated land, and that was in some years ago, I think 8 years ago. And since then, we haven't anything new. And I think it's an opportunity for us as industry to start influencing the regulatory regime going forward, because if we don't, they may come up with something that is not addressing what we see and what we know on the ground on a daily basis as industries.
Yes. So we do, they are invited to our conferences and they do attend. And also, as Margaret just showed you at the beginning of this, we were invited to the Waste Choral where we got an award for the work that we are doing as NICOLA, not me personally, but the organization. So we do very much work closely with Himpo and his team at DEF as best we can. I mean, we're not working for them, but we collaborate.
Sorry, just in the interest of time, we got 2 more questions already in the chat box. The first question is, will the presentation be shared? As far as I'm aware, we don't normally share the exact presentation, but we have recorded this session and the recording will be shared. So I hope that helps answer that question. And then the other question is in terms of other ways to confirm successfulness of the system once it's installed. Steve, I don't know if you can take that question.
Yes, I see that question. Yes, so typically what we do is we have an OM&M phase, operational maintenance and monitoring phase for our SSDs, where you would go back over a period of time, normally quarterly, and you measure pressures and flow of those systems to make sure that they are operating. And then the other thing which you've mentioned in your question is then to take samples. So yes, at some sites, in fact, most of our sites, we go back and we'll take indoor air samples to confirm that the SSDs are in fact working. But mostly the OM&M is about confirming pressures and flow of the system, that it is in fact operating. Because if it's operating the way it was designed, then it should be doing its job in keeping the vapors out of the building.
Okay, I think we are over time. Is there one last question? Anyone else want to come off mute or put their question in the chat box?
my side, the last question for me, Steve.
Yeah.
The soil space. Anything have you ever find the soil space playing some roles in the migration of the vapor to the buildings?
When you say the soil space,
like the soil spores. Like for example, if the product leaks and then because of the spaces on the soil horizon, do you see any correlation in your data or something that you might have presented around the vapor intrusion with the soil spores?
the soil pores. No, I mean, it obviously migrates through the VEDA zone, and it will migrate between the soil spaces towards it's at the rate of diffusion. But no, I don't have any other specific information on that.
Okay, thank you.
All right, thanks very much, Steve. Much appreciated. Thanks very much for your presentation. We will be sharing this recording. Rochelle will be sending it out. So if you would like to share it with anyone who missed it, or if you'd like to see it again, it will be made available. And just remember the CPD password is yellow peaches for you to get those CPD points. So we'll see you all next time for the next presentation. Thank you very much.
Thank you, Margaret. Thanks.